Hello, we're back again. In this short video, I will show you how to interpret areas under the standard normal distribution curve between z-score boundaries or utilizing z-score boundaries. I will remind you that in your class I have in module 2 or week 2 down at the bottom, I have provided you with the z-score tables. So these should be helpful to you. We'll get started here. Do you remember this thing? This is a standard normal curve because the mean is 0 and the standard deviation is 1. And I'm going to show you why we need z-score tables. This one we found the area of. It was really quite easy. On right here we had 50%. We know right here we have 34%. So 50% plus 34% is 84%. So 84% of the data lie to the left of a z-score of 1. Now, what if we moved the z-score to 1.37? What would we do then? Well, the problem is we know that this is 50%, but we don't know, we know from 0 to 1 is 34%. Well, what about 1 to out to 0.37? See, there's the problem. We need tables that give us the ranges or the amount of areas underneath the curve for any of these values. When z equals 1.37, we need a table to give us the area. And here we are. Guess what? This table is a table for the standard normal distribution curve for a z greater than or equal to 0. Z-score tables are use the standard normal curve where mu equals 0 and sigma equals 1. They look like this. So what we're going to do here is we're going to read this and we're going to find z equals 1.37. So we have to do that in pieces. First of all, we find z equals 1.3, and then we find, because that goes down this side, and then we find 0.07. Let's see what that looks like. Here's 1.3, and here's 0.07. So the area underneath the curve to the right of to the left of a z-score of 1.37 is 0.9147, or in other words, 91.47% of the data lie to the left of a z-score equals 1.37. You just have to learn to read the tables, and they're not really very hard to read. The notation would be, what is the area for a z-score 1.37, or to the left of? So it's 0.9147 or 91.47%. What if we were to try to find the area to the left of negative 2.47? Well, you have two z-score tables. You have the positive table and you have the negative table. The positive table, remember, are those z-scores greater than mu, and the negative are those less than mu. So if we look for negative 2.47, we would find negative 2.4, and we find negative 2.4, and then we find 0.07, and lo and behold, we have 0.68% of the data lie to the left of a z-score of negative 2.47. So we're able to find this. Now, when reading z-score tables, the first thing you have to do is determine if you have a positive or a negative z-score. You select the proper table. You have a positive table and negative table. You divide the number into two values. One value has a whole number and a decimal number. The other value has a decimal, a 0, and a number. So we can make this thing work. You locate the first half on the left. You identify the second half at the top. The areas at the intersection of those two values. I want you to look at that again. We divided it into negative 2.4, and then we had negative 0.07. And there at the intersection of them, we found the area. So the steps are really very, very easy to use. This is an easy process, one that you just pick up steam. Now, I want to tell you that there are actually calculators that do this. Right now, we're doing it by hand because I want you to get a good feel for what we're really given when we're given the area underneath the curve. I don't care if you have a calculator that does it. Life is good. Technology is wonderful. This is easy, and you're going to master it. So keep climbing the ladder. You've got this.